Armin Ronacher, I don't know how to pronounce it in English, but it's a German or Austrian name anyway, so it's fine, I guess, who's a member of the Pi team, published a pretty interesting article, which is worth reading, obviously. That's why you find it below. And this article, I think, has implications for all of us. And it is about a topic which I personally did not think too much about until now. So I want to share it with you. Now, Pi, in case you don't know, is a pretty great, very minimal agent harness, which you can totally make your own. It has an amazing extension system, and it starts minimal, and you can turn Pi into exactly the AI agent you want. I'm a big fan. I've been using it for many months. And coincidentally, indeed, because I didn't know that the article would come out, I have created and released a Pi course a couple of days ago. It's currently on offer because I got asked about it a lot. It's an amazing tool, and in this course, I share all about the setup, the configuration, the core features built in, how to make Pis yours and extend it, and yeah, all that stuff. So if that's interesting, you can also check this out. It's an amazing coding agent either way. And this article is also pretty interesting. Now, in this article, Armin talks about an issue you can see if you're using Pi, for example, with your OpenAI subscription, for example, with a model like GPT 5.6 Sol. You can analyze your Pi session logs, so to say, on your system. So these are simply JSON-L files, which are created for each Pi session you start. And in there, you find all the turns in that session, all the messages sent. So the message sent by you to the model, for example. So here, that's the message I sent it. And then also the responses you get back, the results of the various tool calls that were made, and so on. That's all logged in there. Now, why does this matter? Well, of course, when you use a coding agent like Pi, and it's not just Pi, that's in general how they work, the idea is that the agent runs on your machine or maybe on a remote machine, but typically on some machine you own or control. And of course, the large language model, the brain behind the agent, typically does not run on your machine, but instead on some remote server served through an API, for example, by OpenAI, if you're using their subscription or their API or Anthropic and so on. So there is this communication between your machine and their server, and we've all seen this when their servers were overloaded and down again. And in order to have a real conversation and a session where the context builds up over time and the model can work its way through a problem by gathering more and more information and performing more and more steps, in order for that to happen, you need to manage the context of your session. So you need to keep track of all the things that happened, and that context here must be sent to the large language model, because on its own, by default, every new request this large language model receives is just one request, some text input where it can produce some text output. Now, if it wants to call a tool, that only happens because AI agents, AI harnesses like Pi, do send tool descriptions along with your prompts. So tool descriptions are part of that context in the end and are sent to the LLM in addition to your prompt and other instructions. So it's this package here that is being sent to the large language model with those requests. And then the large language model can make decisions and can ask to execute a tool. So it can respond with a tool call request, but it's then in the harness on your machine, for example, where the tool is actually executed. And I guess that makes sense. If the model decides that it wants to read a file or write a file, that file is on your system, so it can't do it on the OpenAI servers. And even if for some reason the file should end up on those servers, even if that would be the case, the model, the large language model, can only produce text that has not changed since the release of ChatGPT. They take text input, they produce text output. So all they can do, which still makes them very powerful though, is describe tool use intents, you could say. The model can describe that it wants to read a file, but it can't do it on its own. Anyways, that tool call request is then received by the agent or by the harness if we want to be precise, and then the tool is executed on your system, the file is read, and then the result of that, so the tool call result, is sent back to the large language model and is also part of that session context, because ultimately it's of course that session context that builds up with all those prompts, with all those answers, with all those tool call results and so on, and that is always sent to the model. So that's important to understand. It's this session that's in the end sent with every turn, you could say, to the model so that it has more and more information available as this session builds up. Okay, now what's the problem with that? The problem with that is a session entry like this. The assistant, so the model, replied with some thinking tokens, you could say, and that is a feature all these frontier models have these days. They are reasoning models, which means they don't just output final responses or tool call requests. They can also output intermediate thought processes, you could say, thought processes that then lead to tool calls or to the final message they may send back. The problem is that what you get these days by some of these models, like GPT-5.6 Sol on OpenAI, you only get a short summary of what it reasoned about and not the full thought process output. Instead, the only details you get is a bunch of unreadable stuff here. You get some encrypted content, but the kicker is you can't decrypt that encrypted content. Only OpenAI can. So you're not getting the full thought process. You're just getting a summary and some unencryptable encrypted content. Now, of course, when that session here, when that context here is sent to OpenAI with the next turn in the conversation, then OpenAI can decrypt that content on their servers. So the thought process is not lost, it's still there, but it's invisible to you. And why is that a problem? That is one of the main things Armin talks about in this article. And again, there are more interesting things in there. You should read it. But why is this specifically a problem? Well, one problem I have with that is, of course, transparency simply. You can't see what the model thought about. You can't see if it evaluated some options you're not too happy about, and you could then maybe tell early that it's going in a wrong direction. You have no idea of what it thought about because it's transparent. All you get is a summary. So transparency is one problem. Related to that, I have a problem with billing. You are billed for all those thought process tokens, not just for that summary you see. So you are paying for tokens you don't see. You don't see if OpenAI is billing you correctly. Now, you don't have to assume that they're cheating on you, but you have no way of auditing or controlling this. And that's also not a great feeling. Paying for something where someone tells you, this is the right price. Not great. But one of the biggest problems I have with that, and that is also the main problem Armin mentions in this article, is that suddenly you don't own the session anymore. I mean, if that session, as it is stored on your system, no longer accurately represents what was going on, it's not worth a lot. And what do I mean with that? This will work as long as we keep on sending this to OpenAI and keep on using this model. It may also work if we switch to different models, but that's already one part where we have to rely on the provider to ensure that this works cross-model, that this encrypted content can be decrypted when using a different model by them. It absolutely will not work when moving to a different model by a different provider. Now, why would you switch model in session? Well, there are reasons for that. One could be that OpenAI is offline again. Another reason could simply be that you maybe plan or discuss something with, let's say, GPT 5.6 Sol, but then you want to implement it with Grok 4.5 because it's faster, it's cheaper, whatever. So you may want to switch the model because of reasons like this. And another reason could also be that maybe you worked on a feature a couple of months ago. By now, there are new models out. Suddenly, you want to continue an old session because maybe you need to fix a bug related to the feature that was implemented in this session. Obviously, you want to do this with a new model at the point of time where you want to fix the issue. But maybe even when sticking to the same provider but using a different model, this session doesn't work anymore or does not fully work anymore because maybe that content can't be decrypted anymore. And it certainly, as mentioned, doesn't work if you switch to a different model provider. And these may all sound like niche issues, but combined, they can become real issues. And it is not great that you're losing and that I'm losing ownership of my sessions on my system. Now, why does OpenAI do that? And by the way, it's not just OpenAI, Anthropic is the same. They're doing this encryption stuff here to prevent distillation or make distillation harder because they don't want those Chinese or other companies to train their models on their models. And I could make a deep dive here about how weird this stance is, given the fact that they trained their models on all the open internet, essentially, and beyond that. But that's not the focus of this video. There is a lot of hypocrisy here, but this is not what I want to get into here. But that is why they are encrypting it. Now, this is not the only problem you could run into and not the only thing Armin mentions in his article, but it's one main point he makes here. Another interesting point is related to tool calls. Remember, I mentioned that large language models make tool call requests, and then it is your harness or running on your system that actually performs the tool call, that reads a file, and so on. For some tools, this could be skipped. Let's think about a web search tool. Web search doesn't have to happen on your machine. And indeed, outsourcing web search may sound interesting because it's not trivial. If it happens on your machine, you will most likely work with some third-party API or provider because you, I guess, don't have your own web search index. You have no crawler that crawls all the websites, right? So if you want to have a web search tool or some web search capabilities in your agent, you will likely use a provider. And you can absolutely build your own web search tool on top of a provider like Brave or Google, and a bunch of possible options there. But what many of these model providers like Google, but also OpenAI and so on offer is that they have a web search tool. And they offer you that when you send a request to a large language model, they will use that tool automatically for you if needed by the request, if the model makes the decision that it should perform a web search. And then this entire cycle of the model requesting the tool call and the tool call being made and the results being analyzed, all that would then happen on the OpenAI servers. And what you get back for your initial request is not a detailed report of what happened, is not a list of the searched URLs along with the per page content, but instead what you get back in the end is just a summary of the web search results along with the source URLs, which you then can of course inspect on your own, but you don't get all the details. You don't see what actually happened, what was considered, what was analyzed in that web search request. Now, obviously you don't have to use these capabilities, but you may have turned it on by accident, or you may find it convenient to outsource that and let them do it on their servers. And there are good reasons for doing that. But of course, if you do use that feature, for example, here at the web search example, you again lose some ownership over your session. Suddenly, I don't know if I have a web search tool call in there. I don't think so. But suddenly you just get a summary and not the details. So again, some information lost. And if you would port that context here to a different model, the model would only see that summary and not all the details from that web search as it happened. So another important point here. Also important is this point here about compaction. You know, if you have a conversation with a model, or if you're building up that context during a session simply, it may eventually, for bigger, more complex tasks, run out of context window space. All these models have different context window sizes, and depending on the task you're tackling and what's going on in there, that context window may fill up. If that happens, a process called compaction kicks in, which simply means the Agent harness normally takes the current context, so takes all the content in here and summarizes it, creates a summary with help of a large language model, and creates a fresh context window and puts that summary in there. That's in a nutshell what happens. It's a bit more elaborate than that, but that's in a nutshell what happens. Now, some model providers like OpenAI offer a feature called server-side compaction, which means they manage the context for you. They can compact for you on their servers. Why would you do that? Well, this compaction can be more powerful than the trivial compaction you perform on the client side with the summary. They can store more complex data there, simply not just a summary text, but maybe a more complex object they can store on their servers and reference that from the new context. So more information can maybe be kept and maintained despite compaction happening. So it can be a useful feature, but if you are using that feature, and it's not like you have to use it, right? That's important. But if you do use it, again, suddenly you lose information. Suddenly that compaction information lives on the OpenAI servers, and all you get back is a key to that compaction summary or an encrypted content. So suddenly you no longer own that compaction summary. You just own a key to some point in the OpenAI servers or to some database on the OpenAI servers. And that again means your session lost information. A similar problem can occur if you're relying on OpenAI, and again, other providers have similar features, on OpenAI's conversation state feature. And Armin mentions this too. You know, in these sessions, we obviously keep track of everything that happened. That's the idea, that the agent harness manages that for us so that we can easily port this to different models and so on. And of course, also in case of Pi, to enable its amazing tree command and so on. So the agent harness keeps track of the session and everything that happened in there on our system, as I explained. Now, you could outsource this. OpenAI, for example, offers their conversation state API, which means instead of manually keeping track of what happened and sending that to the model with every new request, you let OpenAI handle it. You can set a store property when using their SDK to true. If you set it to false, then they don't store the conversation. You have to store it. You have to store the session. If you set it to true, on the other hand, and indeed it is set to true by default, so you have to set it to false to manage it on your own. The default is that they manage it for you. If you set it to true, then they actually will manage the conversation on their servers, the context on their servers, and they will give you a response ID with every response. And you can send a new request with just the next message in a conversation and just reference a response ID you got earlier. So whenever you get back a response, you just store the response ID, and with your next message, you reference that last response ID. And that way, OpenAI on their servers knows to which conversation this new request is referring, and they keep on managing that context, that session on their servers. Of course, the advantage of this approach is that less data, for example, needs to be sent over the wire. Less data because if you're managing the context and the session, then this entire chunk of information has to be sent to the OpenAI servers, for example, with every request your agent harness makes. Obviously, because otherwise the model on the server wouldn't know what's going on. Because by default, not by default anymore, because by default it stores it, but if that is turned off, it is stateless. That's the way I should put it. But if store is not set to false, if you use the default settings, then they do store that context. So yeah, you only have to send your new message. You don't have to send the entire context with every new request. Convenient, right? Sure, convenient, but suddenly you don't know what's going on. You're not storing the session anymore. You can't switch at all. You have basically no information about what was going on because the context is not there for you. And that's why in this article, Armin also says that store false is available and should be used because otherwise the default is true and they manage it for you. But all these things, all these little improvements that are happening here to make your life easier have the impact I described earlier. That there's less transparency, that you have to wonder if billing is correct, that you can't audit it, and that maybe most importantly, you don't own the session anymore, with all its implications like reduced or no portability, that you may not be able to come back to a session in the future if the model provider doesn't support it with newer models. And that's all a bit of a worrying trend. A trend, as I said initially, I didn't fully anticipate or think about, to be very honest, because I'm not in the business of building agent harnesses. And it's just not something I spent a lot of time worrying about. I do worry a lot more about it now. And I don't see these model providers going back, especially since they want to defend against distillation. In their perfect world, they certainly have all your data, all your conversations on their servers, and you only send your tasks. That is certainly their perfect world, because that gives them way more control. And in general, I am the kind of person who likes to stay in control. And these trends are making me have less control over my work with AI. These are my thoughts on that. Please share yours.